Today we're going to start our factoring of polynomials, and we're going to start with a very specific polynomial, the quadratic. So first we're going to look at the graph of the quadratic function. To graph it, we need 3 good points to kind of get a sketch. I'm not expecting 100% accuracy, but a good sketch of it. So the first point, first of all, the quadratic function y is equal to x squared. This is the parent function with nothing added to or subtracted from the function itself. It is the most basic form of it. First point we're going to look at is the minimum point, because the quadratic has a shape of a U. Where it changes direction is either going to be a minimum, and if we reflect it across the x-axis, it is going to be a maximum. So the vertex is either at maximum or the minimum, and it is also a point on the line of symmetry. So this is a symmetric function. Second point that we're going to look at is from the dilation factor. So using that in the parent function, we know that a is equal to 1, so that means if we move 1 to the left, we have to move 1 up because of the square. So negative 1 squared would be equal to 1. We're also going to find a third point by moving 1 space to the right. So x is equal to 1, and 1 squared will give us an output of 1. So there's a second good point on the parent function. Next, we're going to look at if the graph translates on a coordinate plane. I still need 3 good points on the graph, but the graph is positioned a little bit differently. Well, we can see it crosses the x-axis at a point somewhere where it touches the x-axis. It's the x-intercept. It is also called a root of the function. It's also called the solution of the function, because that's where y is equal to 0, so we can solve for x. So we actually have 2 of those in a quadratic. Third point we actually have, both of those are x-intercepts, y is equal to 0. Third point that we have is the vertex at the bottom of the curve. We know that this is a minimum already because it's at the bottom of the curve. And it's called the vertex. But the vertex also tells us the x value, or the axis of symmetry, and what x is equal to. So in this case, x is equal to negative 2. Okay, so we'll be finding the axis of symmetry along with the zeros of the function, solutions of the functions, x-intercepts, and the vertex. Now, these are the same space away from the axis of symmetry. Well, we know this because the axis of symmetry splits our function in half. So the distance from the point on the left to the axis of symmetry has to be the same as the distance from the point of the x-intercept on the right to the axis of symmetry. This will help us a little bit later when we have to graph, if we have to find other points other than the intercept to graph it. You know, the axis of symmetry goes right down the middle, and we can use that to help us find other values on the graph. Okay, so we will be graphing as we go through this, but the main part of this is actually solving these algebraically. And the quadratic function comes in 3 different forms. The first form we've been working with, which is the vertex form. This is the form that has a, h, and k in it, where you know a is the dilation, h is the x value, and k is the y value, actually, of the vertex. So the vertex is located at negative h, comma k. Remember, h is always opposite. So another form we're going to be using is the standard form. Well, we can make a data table to be able to graph this. We can't graph that very quickly. And in the data table, the points aren't necessarily accurate. And we generally want to put it into the third form, which is the star of the show for this unit, the factored form. So if you remember the word factored, the factor means that we are multiplying two things together to make the third. So if I multiply these two binomials together, I can get the standard form. Generally, we do not move to the vertex form. Generally, we just graph the vertex form. But we are able to move between all three forms if needed. Okay, so we're going to start factoring. Right? Remember again, factoring a polynomial means expressing it as products of another polynomial. So if you remember in middle school, elementary school, the factor of a number is the product or the products of a number that multiply together to make that number. So this is the first method or the first thing in factoring. So the first step in factoring is you need to factor the polynomial for the GCF, or a monomial that is a GCF. We have to always look for that first. Always look for that method first. So the GCF is the first thing that we do whenever we are factoring. So the first step in finding the GCF is finding the GCF, the factor. Okay, the second step you're going to do after you find the GCF of all the terms in the polynomial is to write the quotient, the remainder as a quotient, whatever's left as a quotient, right? Then we want to express it as a product, the quotient times the GCF. Okay, so let's look at an example. So what we have here is 6c to the third d minus 12c squared d squared plus 3. So we have a couple things going on here. First of all, let's just look at the numbers before we even look at the variables. We have to find the GCF between the numbers. One little quick way, a lot of times, is you take the smallest value and you divide it into the others to see if it goes in evenly. Well, we do know 3 goes into all these. So 3 goes into 6 twice, goes into 12 4 times, and goes into itself once. We also know that we have variables here. Well, we have the variable c in all 3, so we have to make sure it's in all 3 of them. If it isn't in all 3, it's not going to be common. We have to find the GCF for all 3. Well, if we look at this, this has 3 c's, this one has 2, this has 1. So only 1 c is common to all these. So that means we have to divide out 1 c. So we have 3 and c coming out. Let's check the d. Well, there's 1 here, there are 2 here, and then there's 1 here. So that means that 1d is common to all these. So we need to factor out a 3cd. So that means our GCF is 3cd. So the second step is divide to come up with a quotient. We're going to divide the GCF into all the terms. So 3 goes into 6 2 times. Well, let's go with 3cd divides into 6cd. It's going to go in there 2c squared times. Then it has to go into negative 12. So 3 goes in there, 4, keep the negative, right? So minus 4 cd, and then 3cd divided by 3cd is going to be 1. So we divide all of them, and our result is the 2c squared minus 4cd plus 1. But remember what we have to do in the next step, the third step, is after we have found our answer to our quotient, we're going to have to set it up like a product. So here's our example again. And next we have to take what we divided out, the 3cd, and put it in front of the quotient. answer to the quotient. So you can check, if you multiply this back in, we're going to get 6c to the third d. That's what we have here. You take 3cd, multiply it back in, we get our 12c squared d squared. 3d, or 3cd, and times 1 is 3cd. So if we multiply it back in, we actually get the same thing up top. So that means we actually factored it correctly. Okay, on the next slide, you're going to try factoring some of these. So please, try factoring these and pause the video to give yourself a chance to answer. Let me see if you do it correctly before you move on to the practice problems that I have planned for you. So, you want to factor these. Pause the video and try these 3. All right, so the first one, you want to figure out what the GCF is between the numbers. Take the smallest value, 3, and 3 goes into 6 and it goes into 12. So the GCF is going to be 3. And then here's the quick cheat, is to look at our variables, figure out which one is the lowest variable. That's going to be x. So 3x is our GCF. But we need to make sure that we write it as a product of two numbers if we're going to make it equivalent. So 3x is the GCF, goes into this 2x squared times 3x times x is 3x squared minus 4 times 3 is 12 times x. So this is the solution. Taking a look at number 2, looking at the numbers, 5 goes into all these. So 5 comes out. There are no variables that are all in all 3, right? We have 2 x's here and x here and no x's here, so x is in common. So only 5 comes out as the GCF. And the product is x squared minus 2x plus 7. Look at the last one. Wow, it looks really complicated, but we're going to ignore the variables at first. We're just going to look at the numbers. Well, the smallest value you have here is 8. 8 does not go into 12 evenly. So 8 cannot be our GCF. Well, we need to look at 8 and what numbers go into 8, 12, and 16. It's going to be 4. So 4 is part of the GCF. Now let's check out the variables. X to the third, x squared, x. So x is the smallest. So take out 1x. So we have 4x so far as the GCF. Let's look at the y. So we have 4 here, 2, and 3. So squared is the smallest. So a y squared is going to come out. And now z, we have 1 here, 3 here, 2 there. So z is going to come out. So our GCF is 4x y squared z. And we have to divide that into each one of these terms. So 4x y squared z is our GCF. It divides into 16 x cubed y to the 4th z, 4x squared, y squared times. 4 goes into 8 2 times. X goes into x squared, x times y squared is 1, so you don't have a y in this one. They go away, came out, got factored out. And then 3 into 3 squared is, or z into z cubed is z squared. Plus, let's say 4 goes into 12 3 times. X over x is 1, so there's no x's here because it got factored out. And then y squared goes into y cubed, leaving 1y. And then z squared divided by z leaves 1z. Okay, so now you're able to move on to the activities I have planned for you in terms of factoring out with the GCF.